Hello, welcome back. In this session, we are going to discuss about a new algorithm strategy, greedy method. So, greedy method is one of the important algorithm strategies used to solve a variety of problems, mostly complex problems. So, we'll be discussing some examples based, based on which we apply the greedy method. So now the general method of greedy strategy. So normally we'll be facing problems, or we'll have to solve problems with n inputs, and we may be required to obtain a subset that satisfies some constraints. So any subset that satisfies these constraints is called a feasible solution. So now we need to find a feasible solution that either maximizes or minimizes the given objective function. So greedy method will be so the greedy method is well suited for obtaining a feasible solution that maximizes the given function. So when you look at the key concepts which we use for applying greedy strategy, first of all, we should know what is a feasible solution and what is an optimal solution. So, given a set of n inputs, we may have to find a subset that satisfies some constraints. Those subsets that satisfies the constraints are termed as feasible solutions. There may be more than one feasible solution for a given problem. So, out of those feasible solutions, we need to choose one that optimizes the given objective function. So the objective function may be maximization of some input or minimization problem. So we need to find a feasible solution that either maximizes or minimizes a given objective function. So that feasible solution that does this is called an optimal solution. So in order to find the optimal solution, the greedy method works in stages. So it considers one input at a time. So before adding the input to the solution, it checks whether it satisfies the given objective function. So that's how it works in stages. Let us see how it works. So at each stage, a decision is made whether a particular input is in an optimal solution. Say for example, it's an optimization of profit. So we'll be choosing the input with the highest profit, that yields the highest profit. But it should satisfy the given constraints. Right? So when you add the input with the highest profit, it should not violate or deviate the given constraint. So at each stage, we consider one input at a time. That selection of the input is based on the optimization procedure. So the optimization procedure may be maximization of profit, or minimization of distance, or minimization of time. So there could be any objective function depending upon the problem. So based on the optimizing function of the given problem, the inputs are chosen one at a time. So after selecting the input, the algorithm decides whether it can be added to the solution. So the decision is made based on the constraints. So there may be more than one optimization measures for a given problem. So the algorithm will generate suboptimal solutions. So this greedy technique is called a subset paradigm because given n inputs, we are finding a subset that satisfies the given constraints and optimizes the given objective function. So greedy method, there are two types of paradigms, subset paradigm and ordering paradigm. And a subset paradigm, we are given n inputs, we will be finding a subset. The solution will be a subset of the n inputs. On the other hand, ordering paradigm finds an optimal ordering of the inputs. So it includes all the n inputs, but it finds an optimal ordering of the n inputs that optimizes the given function. So before applying, we should know what are the two types of paradigms, subset paradigm and ordering paradigm. Let us discuss how this greedy method can be applied to solve real life problems. The most popular method is a knapsack problem. Hope you all know what is a knapsack. So before going to the application, let us see what is the general, the control abstraction for greedy method. So algorithm greedy. So we have an array with the n inputs. We define a solution. Initially the solution is equal to 0, and then we use a for loop to select the inputs. So select, feasible and union, those are all control abstractions. Those are all simple functions used in the control abstraction for greedy method. So as we discussed in the last session, the control abstraction, we discussed about the control abstraction of divide and conquer strategy. Now this is a control abstraction for greedy method. So initially the solution will be empty, and then we consider the inputs one at a time. So we choose the input based on the optimization measure. So select function will choose the next input that satisfies the given objective function. After selecting the input, we have to check its feasibility. Feasibility is if we add the input to the solution, whether it violates the feasibility constraints. So the function feasible will verify whether the new input will not alter the feasibility, or whether it satisfies the given constraints. So if feasible, solution comma x, when the selected input x is added to the solution, it should not violate the feasibility constraints of the given problem. So if it does not violate, then x, the selected input, will be added to the output solution. So union combines the new input to the existing solution, and then finally it returns the solution. So this is the general method, or you can say is the control abstraction for greedy method. So the fundamental idea is, given n inputs, we will be finding a subset that satisfies a given set of constraints. Such solutions are called feasible solutions. For a given problem, there may be multiple feasible solutions, but we need to find one solution that optimizes the given objective function. So the control abstraction is given here. So selects an input from the given array. Feasible is a Boolean valued function that determines whether x is included into the solution vector. Union combines x with the solution and updates the objective function. So the most popular algorithm that could be solved using greedy method is knapsack problem. So knapsack problem states that given n inputs, we are given n objects and a knapsack or bag. So each object has its own weight and a profit. So the profit will be earned. Say for example, we assume that object I, there are n objects. Object I has a weight Wi and the knapsack has a capacity m. So if a fraction xi, so the fraction of object that could be added ranges from 0 to 1. So if a fraction xi of object I is placed into the knapsack, then the profit pi into xi is earned. So it's proportional to the profit. So pi into xi is earned. So the objective of knapsack problem is the profit should be maximized. You have to maximize the profit. But there are some constraints. The total weight of the objects added to the knapsack should not exceed its capacity. So the objects should be added to the knapsack in such a way that the profit is maximized, at the same time the capacity of the knapsack is not exceeded. So that is knapsack problem. So we are given n objects and a knapsack of a given capacity. The objects should be added in such a way that the profit is maximized without exceeding the capacity of the knapsack. So it can be mathematically stated as maximize the summation of I is equal to 1 to n pi xi subject to the constraint summation of W is weighted sum of the inputs. So the weighted sum of the inputs should be less than or equal to M. What is M? M is the capacity of the knapsack. And then the value of Xi should not exceed 1. So it should range between 0 to 1. So the knapsack problem can be mathematically stated as maximization of summation of Pi into Xi subject to the summation of Wi Xi less than or equal to M, and the value of Xi lies between 0 and 1. So the profits and weights are considered as positive numbers. Right? So what is the feasible solution here? A feasible solution could be any subset, say x1, x2 up to xn, satisfying equation 2 and 3. So a feasible solution is one that satisfies the conditions given in equations 2 and 3. An optimal solution for which equation 1 is maximized. So an optimal solution is a feasible solution for which equation 1 is maximized. So knapsack problem is a best example for applying greedy method. So for example, we are given 3 objects and then the knapsack capacity is 20. So there are different combinations. So you could see 1, 2, 3 and 4. So the first one yields, the total weight is 16.5, yields a profit of 24.25. The second option, the total weight is equal to 20, but the profit earned is 28.2. The third one, the total weight of the knapsack is 20, profit earned is 31. The last one, last possible combination, say all these are feasible solutions because they don't violate the capacity. All those the total weight does not exceed 20. So the last one yields a maximum profit of 31.5. So we need to formulate how to select the input. So the total profit, the maximization of the total profit depends on the strategy we use for selection of the inputs. So we can try with the 3 ways. The first one based on the profit. So each time we can select the object with the highest profit, or we can select the object with the least capacity used, or the ratio of the profit per capacity, profit per weight. So there are 3 methods by which we can select the input. So when applying the greedy strategy, we have found out that the third method, so selecting the object based on the highest profit per weight yields the maximum profit. So the algorithm for greedy strategy with solving knapsack. So algorithm greedy knapsack, M, N. M is the knapsack capacity, N is the number of inputs. So for I is equal to 1 to N, let us assume initially all the Xi's are set to 0. We use a temporary variable U that keeps track of the knapsack capacity. So initially U is equal to M, and then we choose the input one by one. So here we are choosing the input based on the highest profit per weight. So the inputs are arranged in such a way that they are in the decreasing order of Pi by Wi. So first we add if the weight is greater than U. Suppose if the weight of the object to be added is greater than the available knapsack capacity, then you break, because it should not violate the feasibility constraint. Otherwise you add 1 unit of the object. So after adding 1 unit of the object, the corresponding weight should be deducted from the available knapsack capacity. So we assume the available knapsack capacity is U. Once adding the 1 unit of an object, its corresponding weight should be subtracted. So the current knapsack capacity will be equal to U minus Wi. So this has to be repeated for all the inputs. Finally, if I is less than or equal to N, then xi will be equal to u by wi. Suppose still we have not considered still we have inputs to be considered. If you are not able to add 1 unit of an object, then a fraction of the object can be added based on the available capacity, based on the remaining capacity of the knapsack. So if I is less than or equal to n means there is still some space for adding an input, but not 1 unit of the object. So in that case, we can add a fraction of the object. So that is computed as u by wi. So xi will be equal to the remaining capacity of the knapsack divided by the corresponding weight of the object. So this is how we find a solution to knapsack problem. So to summarize, so in this session we discussed about the greedy strategy. So greedy strategy works in stages. At each stage we need to consider one input. The selection of the input is based on the given objective function. It could be either maximization or minimization. So input is selected and it's added to the solution. But before adding to the solution, we need to check its feasibility. So adding the new input, we should not violate the feasibility constraint. So we have two types of solutions, feasible solution and optimal solution. Our objective is to find the optimal solution. So for we have applied greedy strategy for solving knapsack problem. The knapsack problem states that given a knapsack with a capacity m and n objects, we need to add objects to the knapsack in such a way that it does not exceed the capacity of the knapsack. At the same time, the profit should be maximized. So the greedy implementation of knapsack problem is given here. Hope you understood the algorithm for solving knapsack problem using greedy strategy. We'll discuss other algorithms which could be solved using greedy strategy in the next session. Thank you.